we're going to move to midpoints. And midpoint, you might think, well, okay, from 0 to 1, the midpoint between that would be 1/2. From 1 to 2, the midpoint would be 1.5. And that can work on a function if your function has a physical equation to it. But we don't have an equation set here. So we can't assume, I mean, you could have been going 30 here. There's no set speed that you were going here. So to do midpoints, when we have it like this, is we actually put two intervals together and take the middle of each one. So I'm going to group 0 to 2 together, then I'm going to group 2 to 4 together, and then I'm going to group 4 to 6 together. And in doing that, the midpoint of the first one is 15. Midpoint here is 15. And the midpoint here is 30. So my values that I'm concerned with here are going to be 15, 15, and 30. So I've got one rectangle that's going to do this. Again, it's the interval from 1 to 2. Now, because we're going 2 minutes this time, instead of it being a 1/60th value here, it becomes 1/30th. All right, the next one, again, from 2 to 4, we use the 15. So it comes across like this again. We got 1/30th. And then the final interval is going to be the 30. So we're up here. So we've only got 3 rectangles this time. When you do your midpoint, you're going to end up with just 10 rectangles. So we've got 1/30th, 1/30th, and 1/30th. All right, so again, it's times everything, so we can pull it out front. And it would be 15 plus 15 plus 30. Well, I picked some numbers that are going to work out nice. So it's 60 over 30, which is 2. And again, it's miles per hour times hours, so you get miles as your answer. So that's, I meant 2.0 or 2. So we're going 2 miles in that allotted 60 or 6 minutes of time. That's a decent approximation. I don't know. I made these numbers up, so who knows how far we drove. The last one is trapezoids. And trapezoids frequently will set up a best approximation, because if you trace a curve along it, the trapezoid can tend to hug the curve the fastest. Now, that doesn't mean it's true every time. But what I'm going to do here is I'm going to set up some trapezoids. So the first one is more of a triangle than it is a trapezoid, because I don't have any height here. By next, I come up to 15, so that completes this first trapezoid. All right, the second one here, I've got this, and here's my other parallel side. So my base between the two is this. My third trapezoid comes to here, so that's my third trapezoid. My fourth trapezoid is here. Again, your parallel sides, again, this time are your vertical, so you can think about each one of these trapezoids being rotated 90 degrees, and that's more like what you're used to seeing when you see a trapezoid. Okay, so here's my next one. And then here's my next one. So all of these are trapezoids. This just happens to be a trapezoid with one of your bases being 0, which means it's a lot like a triangle. Now let's think about what the formula for the area inside of a trapezoid is. The formula for the area inside of a trapezoid is 1/2 of the height times base 1 plus base 2. All right. Well, each one of these has a height of, this time it's going to be back to 1/60th. So we've got 1/2 times 1/60th of base 1. Base 1 is 0. And base 2 is 15. All right. Now, again, consistent with each one of these is going to be this 1/2 and 1/60th. So I can factor that out of everything. Now, this is base 1 and this is base 2. My next trapezoid is going to consist of base 2 and base 3. My next one would consist of base 3 and base 4. And then my next one would consist of base 4 and base 5. And then I would have all the way through base 6 and base 7. Okay, so when we clean this up, and I'm going to take these numbers out for just a second, you'll see why in just a second. I end up with base 1 plus base 2, but I have a base 2 here again, so it's 2 times base 2, plus base 3, and base 3 is 2 times base 3. Base 4 and base 4 is 2 times base 4, plus base 5 plus base 5. Again, I put the dot, dot, dot there. So it's 2 times base 5. And then plus 2 times base 6. And then finally, this last base, which happens to be my 7th base, because remember, I've got 7 numbers up here. This would just be plus base 7. So from here, I've got 1/120th of 0 plus 2 times 15 plus 2 times 25 plus 2 times 15 plus 2 times 25 plus 2 times 30, and then finally plus 35. So at that point right there, it's just a matter again of doing the arithmetic. Sorry, I didn't realize that's been off the screen the whole time, but that's what I got set up there. So I would do this arithmetic right here. If you need to pause the video to get caught up, that's fine. And whatever you get, again, that's going to be in terms of miles. But it's based on this principle of you're using base 1 once, base 2 is used twice, base 3 is used twice, all the way through to base 7, which is only used once. And that formula will work on your trapezoidal approximations.